Hi, welcome to Section 7-1 Notes on Ratios and Proportions. So we're covering Chapter 7 now, which is on similarity. So we've talked a lot about congruent triangles, where those triangles are the same shape and the same size. Now we're going to talk about similar triangles where the corresponding sides are proportional to each other. The corresponding angles are still congruent, but the corresponding sides are going to end up being proportional. So if we're going to talk about proportions, we first need to review over ratios and proportions, and that's what Section 7.1 is. So a ratio is a comparison of two quantities by division. So this Section 7.1 should be a lot of review. You should be familiar with this, but again, getting a good review here is going to help you with the rest of the chapter. It says if A and B are numbers where B is not equal to 0, then the ratio can be written in three ways. You could either write it as a fraction, A over B, or you could write it as A colon B, and that represents ratio, or you can write it with A and then the word to B. So those are different ways you might see a ratio. Example 1 says, write the ratio of the first measurement, 3 feet 2 inches, to the second measurement, 4 inches. So if it says from the first to the second, then it's telling you like which number goes on the numerator of the fraction and which number goes on the denominator. So I can say 3 feet 2 inches over 4 inches. Okay, but I have to realize that if they are not in the same units, I can't really compare them very well. So I could either switch it all to feet or all to inches. I'm going to go ahead and go all to inches. So try and think of what 3 feet 2 inches would be in inches. If you think about it, 12 inches are in a foot. So 3 feet is 36 inches plus the 2 extra inches makes 38 inches over the 4 inches. And so now that they're in the same units, I can actually reduce that down. So I can divide 2 into both of those to reduce it down. Just reducing down the fraction. And so that gives me 19 over 2. Okay, or I could write it just like we talked about up above, 19 colon 2, or I could write it as 19 to 2. So any of those would work. A proportion is two ratios that are equal. And the product of the extremes equals the product of the means. So all that's saying is what I multiply in one diagonal has to be equal to what we multiply in the other diagonal. And you can see, that all that's saying is 4 times 3 has to be equal to 6 times 2. For those to be proportional, and that makes sense because we end up with 12 is equal to 12. Okay. All right, the next little bit is some properties of proportion. So you can see here a reciprocal just means we can flip the first and the top and the bottom part of the fraction, or the numerator and denominator. So you can see this A over B is flipped to be B over A. And you can see this C over D is flipped to be D over C. And you can see if I multiply the diagonals, like in this case, if I multiply the diagonals, I get AD is equal to BC. And if I multiply the diagonals over here, I still get, BC is equal to AD. It still means the same thing. So those are equivalent ratios. So next is interchanging the means. So here it says that you can see, this A over C became A over C. A over C vertically, A and C is now A over C. A over C horizontally is now A over C vertically. And then you can see this B and D here in the denominators is now B over D. But again, if you multiply the diagonals, AD is equal to BC, If I multiply the diagonals, AD is equal to BC. They still represent the same thing. We're just kind of switching the information around. The last one is add denominator to the numerator. So you can see here that they did A plus B over B. So A plus B over B, so numerator plus denominator over denominator, and then they just followed the same pattern over this on the other side, C plus D over D. So again, we're going to practice some of those down below. You can see on example 2, you can see it says A over B equals 5 over 8, and they want to know what A plus B over B is. We just need to follow that pattern. You know, A plus B is 5 plus 8 over B, which is represented by the 8. And if I want to go and reduce that down, you know, I can, but, you know, that's all they're really doing there in terms of the pattern of it. You know, if you want to kind of do more with it, you can, and you'd get 13 over 8. Okay, so now on example 3, we're actually going to solve some proportions. They want to know what the solutions are, which means solve for x. So again, what I multiply in one diagonal is equal to what I multiply in the other diagonal. So in this case, I get 5x is equal to 6 times 4, which is 24. And then if I go and divide by 5 on both sides, I get x is equal to 24 fifths. But there's different ways you can write these answers, or you could say a decimal, which is 4.8, or you could answer as a mixed number, which would be 4 and 4 fifths. So all of those represent the same thing. If they don't specify how to leave your answer, any of those would be fine. When I move on to the next one, I've got to be really careful. When I multiply 3 times y plus 4, I need to put parentheses around the y plus 4 because I have to make sure that I'm distributing the 3. And then if I multiply the other diagonal, I get 9y. Okay, so again, don't forget to multiply through by that 3. So I get 3y plus 12 is equal to 9y. And then if I go and solve from there, if I go ahead and subtract 3y from both sides, I get 12 is equal to 6y. If I go and divide by 6 on both sides, I get y is equal to 2. You can always check yourself. If you plug that 2 back into y's place in the original problem, then and simplify that down, then you should end up getting a true statement equal on each side. Okay, next one is going to be a little more to it, kind of a review over from algebra. When I multiply x plus 6 times x plus 1, that's 2 binomials. I'm going to go ahead and put parentheses around both of those to start with. And then when I multiply through the other diagonal, 2 times negative 3 is negative 6. So here's what you need to be careful with. When I multiply 2 binomials, if you remember back from algebra, it's called FOIL, is what your teacher may have called it, first, outside, inside, last. Or she might have just called, she or he might have just called it multiplying 2 binomials. But I'm going to multiply x times x, and remember that's going to be x squared, not 2x. And then x times 1 is just 1x, or you can just write the x. And then the 6 times x is 6x, and then 6 times 1 is 6. All right, and then all of that is equal to negative 6. I can go ahead and combine my like terms together here in the middle. So that gives me x squared plus 7x plus 6 is equal to negative 6. Okay, from there, when I see that x squared and that x, that's my clue that I'm going to have to factor and solve. And so to do that, I need to get everything on one side of the equal sign and 0 on the other side. So you can see here what I'm doing is I'm going to go ahead and add 6 to both sides. And that is going to give me x squared plus 7x plus 12 is equal to 0. So we did a little bit of factoring earlier in the year, if you remember. And so now if we know that we have to factor, and there's a 1 in front of the x squared, we can go ahead and do our 2 sets of open parentheses. And we know that x goes in the first 2 spots because x times x multiplies together to give me x squared. And now remember, it's like a little puzzle that we're solving. Let's show this off to the side. It's like a little puzzle where I'm trying to figure out 2 numbers that multiply together to give me 12, which is the last number here. And I'm looking for 2 numbers that add up to be this middle number, which is the 7. So see if you can think of some numbers that multiply together to give you 12. You might think of 12 and 1. You might think of 6 and 2. You might think of 3 and 4. So you're trying to look for the ones that add or subtract together to give you the other number, which is 7. And so, your 2 magic numbers are going to end up being the 3 and the 4 in this case, because 3 times 4 gives you 12 and 3 plus 4 gives you 7. Okay, so those are my magic numbers. If there were negatives up there on the 12 or the 7, I would have to be careful, if the 3 is negative or the 4 is negative or they're both negative. But in this case, they're both positive. So positive 3, positive 4 is what I'm plugging in here. Okay, it doesn't matter which goes in which spot. So now I have factored it, and now my last step is to actually solve this. To solve it, I need to set x plus 3 is equal to 0 and solve for x, and then set x plus 4 is equal to 0 and solve for x. And in this case, if I get x by itself, I get x is negative 3. And if I subtract 4 on each side, I get x is equal to negative 4. So those are my 2 solutions. Those are the 2 answers that if I plug them back in the original problem, that they would give me a true statement on each side. Okay, if you look at the next part on example 4, it's kind of a little word problem here. And it says, you plan to buy 120 candy bars. The ratio of the number of Kit Kats to the number of Twix bars will be 2/3. How many of each type of candy bar should you buy? So there's different ways that you can do this problem. I'm going to show you the 2 different ways, and then you can decide which way you like better or which way makes more sense to you. One way to do it would be setting proportion, like we were just talking about. Okay, I could say that if I want to figure out how many, say, Kit Kats there are, since Kit Kats are right here and that's going with the 2, okay, then I can say 2 out of the total number of candy bars, which is the 2 plus 3, which gives me 5. So 2 out of 5 is equal to x over the total amount of candy bars we have here, which is 120. And then if I cross multiply, I end up with 5x is equal to 240. And if I divide by 5 on each side, I get x is equal to 48. And that would be Kit Kats. Make sure you put units with your answer at the end. Okay. If I want to figure out how many Twix bars there are, okay, a couple of different ways I could do it. I could either think, okay, well, there's a total of 120 candy bars, and I know there's 48 of them are Kit Kats, then I can subtract 120 minus 48 to get the number of Twix bars. That would be an option. Or I could set up another proportion. I could say, okay, well, for Twix bars, there's 3 out of the total number 5 is equal to, I'll call this one y, over the total amount of candy bars, 120. If I cross multiply there, I get 5y is equal to 360. If I divide by 5 on each side, I get 72 Twix bars. Okay. So again, you sometimes have some options there. Another way that you could think about this is you could think of it as putting, I'll show you up here. You could think of it as putting an X after the 2 and the 3. So you can see, I know the ratio is 2/3, but I don't know how many, like I'm multiplying that by. But one way you could think of it is you could say 2x plus 3x is equal to 120, the total amount. And so I get 5x is equal to 120. And when I solve, I get x is equal to 24. So that didn't actually give me the answer. But if I know the Kit Kats are represented by this 2x up here, then I know I can go, the Kit Kats is 2 times 24, which is the 48. Okay. And I could also say that the Twix is 3 times 24, which is the 72. Okay, so just two different ways to think of the same thing. All right, if we look at the next one on example 5, it says the measure of two supplementary angles is 1 to 4. What are the measure of the angles? So again, same type thing. We can set up a proportion. If you think about it, the 1 plus 4 gives you a total of 5. Think about what the word supplementary means. Hopefully you're thinking that that's two angles that add up to 180. And now we could set up the proportions like we did on the last one. I can say that, one part of the ratio is 1 out of a total of 5. And that's equal to x number of degrees out of the total of 180. And if I solve for that, I get 5x is equal to 180. And if I divide, I get x is equal to 36 degrees. Again, if I want to figure out the number of degrees of the other, I could just go 180 minus 36 to get 144 for the other. Or I could set up a new proportion, which would be 4, which is the other part of the ratio, over the total amount 5 is equal to x over, actually I'm going to use y this time to represent something different here. So I could say y over 180. If I go and solve there, I get 5y is equal to 720. And if I go and divide by 5 on each side, then I end up with 144 degrees. Okay, so that's one way to do it. Again, another option is to set up an equation like we did before. And I could say that, if I think about putting x's right here after the 1 and the 4, I could say that 1x plus 4x is equal to 180, which gives me 5x is equal to 180, which solves and get x is 36. And since angle 1 is represented by the 1x, I'm just going 1 times 36, which therefore gives me 36 degrees. This other angle is represented by the 4x, which is 4 times 36, which then ends up giving me the 144 degrees. Okay, so again, just sometimes more than one way to think about it. All right, next thing it talks about is an extended ratio. Like an extended ratio compares 3 or more numbers. So in this case, it shows you A colon B colon C. It's just saying the ratios of A to B, B to C, and A to C are all true. And this is similar to the transitive property where the two in the middle are the same, those B's. So normally we'd say then the two end things have to be congruent. Now we're saying the two end things have to be have to have an equal ratio or be proportional. So the example it's saying here, 2 to 3 to 5, we can say, okay, 2 to 3, 3 to 5, and 2 to 5 are all ratios that we're dealing with here. Okay. So now down here on example 4, it's saying the lengths of the sides of a triangle are in the ratio of 3 to 5 to 6. The perimeter of the triangle is 98 inches. What is the length of the longest side and what is the length of the shortest side? So again, we've got options of how we can figure it out. If we want to do proportions, we can add up all of these to get 14 as our total. You can see the total perimeter is 98 inches. And so you can see that if it's specifically asking me for the longest side, then I know that this 6 over here is the longest part of that ratio. So I can say 6 over the total amount 14 is equal to x over 98. And I can cross multiply from there and get x equals 42 inches. If I want to set up a ratio for the shortest, then I can say, okay, well, in this case, the 3 represents the shortest length over the total of 14 is equal to x over 98. And when I cross multiply, I get, actually, I probably wanted to do y just to distinguish it as something different. So if I go y, then I can solve and get y is equal to 21 inches. And so that would represent, again, the longest side and the shortest side with what we have above there. Okay. Again, we have another option of how we could solve this. I'm just showing you both ways and you decide which way makes more sense to you. Again, I can put x's after the 3, 5, and 6, and I could say 3x plus 5x plus 6x is equal to a total of 98 inches. If I solve for that, I've got 14x is equal to 98, and I can solve and get x is equal to 7. And now, if I go ahead and plug in, I know that I've got my 3x, my 5x, and my 6x that I'm dealing with. So 3 times 7 is 21 inches. 5 times 7 is 35 inches. And 6 times 7 is 42 inches. And again, the problem is specifically asking for the shortest and longest. So, I could say from that, well, the shortest is the 21 inches and the longest is the 42 inches. I can specifically say that once I figure out what they all are. Okay, so again, just different options of how to do the same thing. And then the last one is a similar problem. If you want to go and try it first and then check to see how you did, that would be fine. It'd actually be probably a good idea. But again, decide right now, which way do you like better and do it one of those ways and then check back to see how you did. So if you like the proportion way, then you might have added those up to get the 20. And it's specifically saying what are the lengths of the sides, not the shortest, not the longest. So you have to find all of them. So I can say 4 over the total amount 20 is equal to x over 60. And if I go and solve for that, I get x is equal to 12 centimeters. Okay, if I go 7 over 20 is equal to x over 60. I can solve, actually I'm going to use a y, I did it again. I'm going to use a y, a different number there. So I could say solve and get y is equal to 21 centimeters. And then my last one would be 9 over 20 is equal to z over 60. And solve and get z is equal to 27 centimeters. So that is one option for finding the different lengths. Of course, the other option is to set up an equation. So I could say 4x plus 7x plus 9x is equal to 60. And then I can solve from there. So I've got 20x is equal to 60. And I can solve and get x is equal to 3. And once I know what that is, I know that 4x is 4 times 3, which is 12 inches. I know that 7x is equivalent to 7 times 3, which is 21 inches. And 9x is equivalent to 9 times 3, which is 27 inches. Oops, and here I changed it to inches and it's supposed to be centimeters. So let me change that real quick. Make it accurate. Okay, so that's supposed to be centimeter, centimeter, centimeter. So either option works. And again, hopefully that is helpful for section 7.1. Let me know if you have any questions and have a good day.